So our next proof is here. We're given that QPS, so QPS, this bigger angle, is congruent to TPR, this bigger angle here. And we want to prove that, I guess, these smaller angles are equal to each other, or congruent. Okay, so we start with our given, of course. So we're going to do angle QPS congruent to angle TPR, and the reason given. Our first step in these problems is the same as our first step in the segment add-pos problems, which is turn our congruency statements into equations. Okay? So we definitely want to do that. And we're going to go ahead and use the definition of congruence to turn the angles, the congruent angles, into measure angle equal to measure angle. So I'm going to do def of congruence. Definition of congruence, there's a definition of congruent segments theorem, and there's also a definition of congruent angles theorem, right? So we're able to do this to turn the congruent statement into a equation. So from there, what do? Well, we have no more givens, right? And so we can't apply any of these strategies because we're not given perpendicular lines, we're not given vertical angles, we're not given comp statements, we're not given, two angles that form a right angle or linear pairs, or any of this stuff. So what do we do now? We do this. If the figure has two adjacent angles, then we use angle add-pos, right? So if we have this situation here, what does angle add-pos let us say? That the first angle plus the second angle equals the whole angle. In this case, it'd be PQR plus RQS is equal to PQS. So that's what we're going to do over here. But in this situation, it's a little bit different because we have three adjacent angles. So what we can do is we can go ahead and cover up that first angle and apply angle add-pos. Right? And then we can cover up this angle over here, or this ray down at the bottom, and apply angle add-pos again. So that's what we're going to do. And that's what we have here for statement C. All right. So QPS, this big angle, is equal to the first angle QPR plus RPS. Right, first angle plus second angle equals the whole angle. And then same thing on this side is TPS, the first angle, plus SPR, the second angle, is equal to RPT, right, or TPR. Okay, so then the reason is going to be angle add-pos. Okay. And so now what do? Well, we've done everything we can. We've turned the congruency statements that are given into equations. We've looked at the figure and applied angle add-pos. So now we have these three equations. We now need to use substitution to get to this proof statement. So we're going to explore, right? You don't know how to do that, so we just try, and eventually you're going to run into the substitution that works. Okay. But what you want to notice here is that we have this equation QPS is equal to this expression, and we have TPR is equal to this expression. Right? And the equation we have up here is QPS is equal to TPR. So what we can do is we could take what QPS is equal to, namely this expression here, and we could replace it anywhere, we could place it anywhere we see measure angle QPS. And where do we see measure angle QPS? Well, do we see it in this equation? No, but we do see it in the first equation. It's right there. So I'm going to take this expression that QPS is equal to, I'm going to put it right there in the place of QPS. And if you look, you can see that TPR is equal to this expression down here, and we can go ahead and take that and replace it, or place it, substitute it in the place of this measure angle TPR. So what do we get when we do that? It's measure angle QPR plus measure angle RPS is equal to measure angle TPS plus measure angle RPS. All right, so that's what we did. Right now we have this equation. What do we need? Well, we want QPR is congruent to TPS. We want QPR equal to TPS, these two equal to each other. We want these two expressions to go away. All right, these two terms we want to go away. And notice they're the same term. It's the same number, right? Measure means number of degrees in this angle, and we have measure angle RPS. We've got two RPSs, one on the left side of the equation, one on the right side of the equation. So what we can do is we could subtract, right? I don't have enough room to write it all out here, but it would be measure angle QPR plus measure angle RPS minus angle RPS is equal to measure angle TPS plus measure angle RPS minus measure angle RPS. Right? I don't have all the room here, so I'm just going to do minus measure angle RPS on this side, and I'm going to do minus measure angle RPS on the right side of the equation. So what am I doing here? I'm subtracting RPS from both sides of the equation. What's the property that lets me do that? Well, we should be well versed with the algebraic properties, and that's the subtraction property, right? So I'm going to put subtraction property. Now what do? Well, now we can go ahead and replace this expression with what it's equal to, right? So what is measure angle RPS minus measure angle RPS equal to? It's 0, and it goes away. So it's measure angle QPR is equal to, and now what am I going to do over here? I'm going to replace this expression with what it's equal to, namely 0. It goes away. So we have measure angle TPS. What lets me get to that statement? Well, we're replacing an expression with what it's equal to. We're replacing an expression with what it's equal to. This is substitution. Lastly, we need to go from measures to congruency statement, and so we need to say angle QPR congruent to measure, angle TPS, and the reason is going to be definition congruence. And we are done.